transformations of the graph y is equal to f of x. So there are 4 different things that we will look at in this video. We will look at how the graph can be translated up or down. So this first example here, the graph has been moved up. So the original is the black curve, y is equal to f of x. And the blue curve is the new graph, and it's been moved up by a scale factor of a. So plus a is added on to the end of f of x. And this could also have been moved down if this was a minus. We'll look at this in more detail in a few minutes. The graph could have been translated left or right otherwise. So again, the black curve is the original curve, so y is equal to f of x. And the blue curve is the new graph, and that's y is equal to f of x plus a. So there's some positive value added onto the x. And what happened was the graph was moved to the left. If this had been a minus, it would have been moved to the right. Again, we'll look at that in more detail in a few minutes. Otherwise, the graph can be stretched. So the black curve is the original function, y is equal to f of x. And the new curve is the blue one. And we can see that it has actually been shrunk, even though we use the word stretch for either of these. It has actually been shrunk, so it's gone skinnier than the original function. And there is an a stuck onto the front of f of x, so some positive value that it's been multiplied by. And then alternatively, we see the a can be inside the brackets. So the original function is y is equal to f of x, so that's the black curve. And this time the x has been multiplied by a, so some positive value a. And we can see that the graph has been stretched going inwards this time. So it's gone skinnier. And notice that the minimum points are the same, whereas with the graph above, the minimum points were different. So we're first going to focus on graphs that are translated. So moved up or down or left and right. So if the value is added on or subtracted to the function, so it's not inside the brackets, so we can see down here that the plus a is inside the brackets, whereas up here it's outside the brackets. So if it's outside the brackets and it's positive, we move the graph up. If it's negative, we move the graph down. Whereas if the value is inside the brackets, so in this case it's x plus a, so that could be x plus 3, x plus 5, x minus 2, and so on. Whatever it is, if it's inside the brackets, if it's positive, it moves left, the graph moves left, and if it's negative, it moves to the right. So we're starting with the graph y is equal to f of x, which is equal to x squared. So this is just our general quadratic graph. So our minimum point is 0, 0. So 1 point on the graph is 1, 1, because 1 squared is 1. Another point on the graph is 2, 4, because 2 squared is 4. Another point on the graph is minus 1, 1, because minus 1 squared is 1. And another point on the graph is minus 2, 4, because minus 2 squared is 4, and so on. So obviously other points on the graph would be 3, 9, 4, 16, 5, 25, and so on. So the red curve is our original function, y is equal to f of x, which is equal to x squared. So the red curve is our original function. And we see that 1 has been added on to the function, or 1 has been added on to the x squared. So notice that the plus 1 is outside the brackets. So if it's outside the brackets, the translation moves up or down. So if it's positive, it moves up. If it's negative, it moves down. So we have plus 1. So we can see that the minimum point was moved 1 step up, and all the other points were moved up as well. But we can really see it when we focus in on the minimum point. So the minimum point was 0, 0, and now it is 0, 1. For plus 2, we can see it's been moved 2 steps up. For plus 3, we can see it's been moved 3 steps up. For plus 4, moved 4 steps up. For plus 5, moved 5 steps up. Now we see some minuses. So going back to our original function, so the red function is our original function, y is equal to x squared. And our new function, which is the blue function, is f of x minus 1 or x squared minus 1. So again, it's outside the brackets. So when it's outside the bracket, we're moving up or down. And when it's minus, we're moving down. So this is x squared minus 1, x squared minus 2 being moved 2 steps down, x squared minus 3 moving 3 steps down, x squared minus 5 moving 5 steps down, x squared minus 6 moving 6 squares down, and so on. So that was moving up or down. Now we're going to look at the graphs moving left or right. So the red function is y is equal to f of x, which is equal to x squared. So although it looks different to the previous function, it's the exact same, it's just the axes have changed. So this is still the graph, this red curve is still the graph of y is equal to x squared. So the blue function is f of x plus 1, which is equal to x plus 1 to be squared. So notice now that the plus 1 is inside the brackets. So if it's inside the brackets, we're translating or moving the shape or the graph to the left or the right. So if it's positive, like it is in this case, we're moving it to the left. And if it's negative, we're moving it to the right. So this is f of x plus 1. This is f of x plus 2, so 2 steps to the left. So again, focusing in on the minimum point. So the minimum point in this case has been moved 2 units to the left, or 2 steps to the left. X plus 3, 3 steps to the left. X plus 4, 4 steps to the left. X plus 5, 5 steps to the left. X plus 6, 6 steps to the left. Again, focus on the fact that the x plus 6 is inside the brackets. So if it's inside the brackets, we're moving left or right. It's positive, so we're moving left. So now we see our new function has a minus. So again, we're inside the brackets, and inside the brackets, we're moving left or right. The translation is left or right. But when it's a minus, we're moving to the right. So again, we're starting with the original curve in red, y is equal to x squared. And since we have minus 1, we're moving 1 step to the right, or 1 unit to the right. X minus 2 is 2 steps to the right, or 2 units to the right. X minus 3 is 3 steps to the right, or 3 units to the right. X minus 4 is 4 steps to the right. X minus 5 is 5 steps to the right. X minus 6 is 6 steps to the right. So just to summarize, when we're translating, if we have f of x plus a, so it's outside the brackets. If it's positive, we move the graph up, we move the curve up. If it's negative, we move it down. And down here we have f of x plus a, where the plus a is inside the brackets. So the rule for inside the brackets, if it's positive, we move left. If it's negative, we move right. So pause the video and try and answer this yourself, and then press play for the solution. So write down the equation of the following graphs. So the equation of this graph is y is equal to x squared. So it's a U-shaped graph. It's positive x squared, so it's a U-shape. If it was negative, it would be N-shaped. And the minimum point is 0, 0. Then we have 1, 1, 2, 4, minus 1, 1, minus 2, 4. So it's y is equal to x squared. Pause the video again and try and work out what the equation of this graph is. Then press play. So the equation of this graph is y is equal to x squared plus 3. So it's the original graph that we had a minute ago in red. It's just been moved 3 steps up. Pause the video again and try and work out what the equation of this graph is. Then press play when you're ready for the solution. So this is the graph of y is equal to x minus 2 to be squared. So notice that the minus 2 is inside the brackets, and it was the original graph, which was in red, moved 2 steps to the right. So that's why it's minus 2. So focus in on the minimum point of the graph to help you. And try this one yourself. So press pause and have a go at it. And then when you're ready for the solution, press play. And this graph has been translated in 2 different ways. So it was the original red graph that we had at the start of these examples, which was y is equal to x squared, which had a minimum point at 0, 0. So it's been moved up by 3 steps and it's been moved to the right by 2. So we have x minus 2 to be squared plus 3. So the minus 2 tells us that the original function was moved to the right by 2 steps or 2 units, and the plus 3 tells us it was moved up by 2 units. So this is our summary again. So we have our translations on the left and we have our stretches on the right. So now we're going to focus in on the stretching. So if we have y is equal to f of x and our new graph is y is equal to a f of x, so the a is multiplied by the f of x, the function. So if the a is outside the brackets, so notice that the a is outside the brackets, it's not inside the brackets with the x, it's outside the brackets. What we do is we times the y value by a scale factor of a. So we times the y value by a scale factor of a. So if this is 3f of x, we multiply the y values by 3. If it's 2f of x, we multiply the y values by 2. Underneath, we have y is equal to f of x and y is equal to f of ax. So the a is inside the brackets, it's stuck onto the x. So if it's inside the brackets, the rule is times the x value by a scale factor of 1 over a. So if it's inside the brackets, the a, we multiply the x value this time. So up here, we multiply the y value. We multiply the x value by a scale factor of 1 over a. So a stretch is an enlargement that takes place in one direction only. It is described by a scale factor and the direction of the stretch. So if we originally had, so just take this square for the moment, so it's not a quadratic graph or a cubic graph, but just let's take the square to see what's happening with the stretch. So we have 1 unit by 1 unit, so length by width, we have 1 by 1. So a stretch of a scale factor 3 in the x direction would multiply that 1 by 3 in the x direction. But notice that in the y direction, so the height of the rectangle, for example, would remain the same. If the stretch was a scale factor of 2 in the y direction, so that original 1 unit would now become 2 because 1 times 2 is 2, but the x axis would remain the same, so the width of the rectangle would remain the same. So here we have our original curve again, y is equal to x squared. And notice this point here, this point 1, 1, because 1 squared is 1. So we're going to use this point for reference in the next few examples. So if the graph is translated to y is equal to 2f of x, or 2 times x squared, the rule is all the y values get multiplied by 2. So the y value in our original point 1, 1 was 1, and the new y value will be 2. Notice that the x values stay the same. Now we have y is equal to 3f of x. So our original curve is the red curve, and our new curve is the blue curve. Y is equal to 3f of x. And notice that the minimum point is the same, but the graph is getting skinnier. So our original point was 1, 1, and that now becomes 1, 3. So the y value was multiplied by 3, the x value remained the same. In this graph, we have y is equal to 4f of x. So the blue curve is our new curve. Again, the minimum point remains the same. 1, 1 is now 1, 4. The y value was multiplied by 4, the x value remained the same. Then we have y is equal to 5f of x. So 1, 1 is now 1, 5. The y value was multiplied by 5. And y is equal to 6f of x. The y value is multiplied by 6. So we have 1, 6. So in this example, we're starting off with the red curve, y is equal to f of x. And if we are interested in y is equal to 2f of x, then all the y values are multiplied by 2. So the brown curve is our new curve. Notice that it is still crossing the x-axis at -2, and the minimum point is still 1. Notice that it crosses the y-axis at a different point, and the maximum points are different. Then the pink curve is y is equal to half f of x. So every y value is multiplied by a half. So our red curve is y is equal to f of x. I want you to pause the video now and try work out what the blue curve is equal to. So focus in on the points. So we had 1, 1, and now we have 1, 2. So press pause and then press play when you have an answer. So the new curve is y is equal to 2 f of x because the y value was multiplied by 2. Now try this example, press pause and have a go at it. Then when you're ready for the solution, press play. Notice that the point 1, 1 has now become 1, 4. So the graph is y is equal to 4 f of x because the y value was multiplied by 4 and the x value remained the same. Now try this one, press pause and have a go at it, then press play when you're ready for the answer. This is the graph y is equal to 3 f of x because the y values were multiplied by 3, the x values remained the same. Now have a go at this one, press pause and then press play when you're ready for the solution. This is the graph of y is equal to 6 f of x because the y value was multiplied by 6. So just to summarize, if we have y is equal to f of x as our original curve, and then we have y is equal to a f of x, where the a is outside the brackets, we multiply the y value by scale factor of a. If our original curve is y is equal to f of x, and we have y is equal to f of a times x, where the a is inside the brackets, we multiply the x value by scale factor of 1 over a. So we're going to have a look at these examples now. We've already looked at those ones a couple of minutes ago. So our original curve is the black curve. So this is y is equal to x squared plus 3x plus 1. And our blue curve, we can see there is 2x now inside the brackets and 2x inside the other brackets. So all our x values get multiplied by a half. So remember, if it's outside the bracket, like we had in the previous couple of examples, the y value gets multiplied by the number itself. But if it's inside the brackets, the x value gets multiplied by the reciprocal. So instead of multiplying by 2, we multiply by a half, so 1 over 2. And notice that the points were minus 3, minus 1, and the new point is minus 1.5, minus 1. So minus 3 times a half is minus 1.5. Notice that the y values don't change. So again, we have y is equal to x squared plus 3x minus 1. So that's our black curve, our original curve. And our blue curve is y is equal to 3x squared plus 3 times 3x minus 1. So 3 has been stuck onto the x on the inside of the brackets. So the rule is all the x values are times by a third. So the original x value was minus 3, and minus 3 multiplied by a third is minus 1. Notice again that the y values don't change. So again, we have y is equal to x squared plus 3x minus 1. So our black curve is our original curve. And our new function is y is equal to 0.5x to be squared plus 3 times 0.5x minus 1. So notice that the 0.5 stuck onto the x is inside the brackets. So the rule is we're going to multiply the x value by the reciprocal. So 1 over 0.5 is the same as 10 over 5, which is 2. Or just the reciprocal of a half is 2, 2 over 1, whichever way you want to work it out. So we multiply every x value by 2. So our original x value was minus 3, and minus 3 times 2 is minus 6. Again, notice that the y values don't change. I'm just going back through these again very quickly. We can see that in these two functions, it's cutting the y-axis at minus 1, and minus 1, and minus 1, and minus 1 again, because remember the y values did not change. So here we have 3 graphs again, 3 curves. So the red curve is y is equal to f of x. The blue curve is y is equal to f of 2x. And the pink curve is y is equal to f of a half x. So for y is equal to f of 2x, all the x values are multiplied by a half because the reciprocal of 2 is a half. And for y is equal to f of a half x, all the x values are multiplied by 2 because the reciprocal of a half, again, is 2. So just to summarize again, if we have y is equal to f of x and then we have y is equal to a f of x, where the a is stuck onto the outside of the brackets, we multiply the y value by a scale factor of a. If we have y is equal to f of x, and then we have y is equal to f of ax, where the a is on the inside of the brackets, we multiply the x value by a scale factor of 1 over a. So try this on your own, please. Just press pause and have a go at it. When you're ready for the answer, press play. Focus in on the points and see what's happening. So the black curve becomes the blue curve. So what is the equation of the blue curve? And it is y is equal to f of 2x, because if we focus in on the x values, so minus 3 becomes minus 1.5. So how does minus 3 become minus 1.5? Well, you multiply by a half, and the reciprocal of a half is 2. So we stick 2 into the x on the inside of the brackets. Notice the y values don't change. Now try this one yourself. Press pause and then press play when you're ready. So the blue function is y is equal to f of 0.5x, or a half x, and it's inside the brackets. So in the original, the black curve, we had minus 3 as our x value, and minus 3 becomes minus 6 by multiplying by 2, and the reciprocal of 2 is a half. So that's why we have a half, or 0.5x, inside the brackets. Again, notice that the y values don't change. Now try this one yourself. Press pause and have a go at it. When you're ready for the answer, press play. So we get y is equal to f of 3x. So the black curve is our original curve. So we have minus 3, and minus 3 becomes minus 1 by multiplying by a third, or dividing by 3. But we're interested in the multiply factor, the scale factor. So multiplying by a third, and the reciprocal of a third is 3. So that's why we have 3 inside the brackets. And again, notice the y values don't change. And try this one yourself and press play when you're ready. So we get y is equal to f of 0.25x, or a quarter x. So our original x value was minus 1. That becomes minus 4 by multiplying by 4, and the reciprocal of 4 is a quarter, or 0.25. So we get 0.25x inside the brackets. This is just a summary again of our stretching. So if the a is outside the brackets, we multiply the y value by a scale factor of a. If the a is inside the brackets, we multiply the x value by a scale factor of 1 over a, so the reciprocal of a. So we're back to our original function again. So y is equal to f of x, which is equal to x squared. So our original quadratic function with a minimum point of 0, 0. And here we see a reflection in the x-axis. So this is the graph of y is equal to minus f of x, or y is equal to minus x squared. So it's been reflected in the x-axis. Notice that the minimum point becomes the maximum point. So here we can see them together. So this is the curve y is equal to x squared, and this is the curve y is equal to minus x squared. So they're a reflection of each other in the x-axis. So here we have another example. So our red curve is our original function, but it's been moved 4 steps to the left. So it was f of x equals x plus 4 to be squared. But now we see our blue function is a reflection of that. So this is f of x, y is equal to minus f of x, which is equal to minus x plus 4 to be squared. So reflecting in the x-axis. For any function f, the graph of y is equal to minus f of x can be found by reflecting y is equal to f of x in the x-axis. So say, for example, this black curve here is x squared plus 2x, and the blue curve is y is equal to minus x squared plus 2x. And we can see it's been reflected in the x-axis. So it still has the same points of intersection with the x-axis, but otherwise everything else is just a reflection in the x-axis. So the minimum point was minus 1 comma minus 1, and that is now the maximum, which is minus 1 comma positive 1. So here we have the curve y is equal to f of x, which is equal to x plus 4 to be squared. And here we have y is equal to f of minus x. So notice that the minus is inside the brackets, which is equal to minus x plus 4 to be squared. So it's now a reflection in the y-axis. So the minimum point, it was minus 4 comma 0. It's now 4 comma 0. Reflecting in the y-axis. For any function f, the graph of y is equal to f of minus x can be found by reflecting y is equal to f of x in the x-axis. So let's say the black curve is the original function. Y is equal to x squared plus 2x. Well, if we put a minus in front of the x in front of each of the x's inside the brackets, we get y is equal to minus x squared plus 2 times minus x. And that gives us the blue curve. So the minimum point was minus 1, and the new minimum point is 1 minus 1. But notice that they intersect the y-axis at the exact same place. And where it did cut the x-axis at minus 2, it now cuts the x-axis at positive 2. Okay, so press pause and have a go at this question by yourself. So our original curve is the red curve, y is equal to x squared. I want you to write down the equation of the transformed graph, so the blue curve on the bottom. So press pause and have a go at it, then press play when you're ready for the answer. So it's going to be y is equal to x plus 3 to be squared because it's been moved 3 steps to the left. Press pause and have a go at it, and when you're ready for the solution, press play. So our new curve is y is equal to x squared minus 3. It's been moved 3 steps down. Press pause and have a go at it. When you're ready for the solution, press play. Here we have y is equal to a half x squared. So notice that the minimum point is still the exact same, but we have a stretch this time. So focusing in on any of the points, let's say we focus in on 1, 1. Just move the bottom of the screen there so you can't really see the numbers, but 1, our point, so our x value of 1 now lines up with 0.5 on the y-axis. So it was 1, 1 in our original function, our red curve, and now it's 1, 0.5. For 2 on the x-axis, we had 2, 4. On our original curve, on our red function, we had 2, 4. And now we have 2, 2. So what's happening is the y values have been halved. So that's why we get y is equal to a half x squared. So the half is stuck onto the front of the x squared. We're now going to look at the transformations of some trigonometric functions. So this is the curve y is equal to f of x, which is equal to sine x. So when you cover the trigonometry chapters, you will get to know this graph very well. So this curve just continues on in this pattern, on and on and on forever in both directions. So it looks like radio waves. So notice that the highest point of the graph is 1. So all the maximum points are 1. And the lowest point on the y-axis is minus 1. So it ranges between minus 1 and 1. So for example, we have 0, 0, and then we have 90 degrees, 1, and then we have 180 degrees, 0, then 270 degrees, minus 1, and then 360 degrees, 0, and so on. So y is equal to 2 f of x, or y is equal to 2 sine x, looks like the blue curve. So notice that the curve still intersects the x-axis at the same places, but now the highest point on the y-axis is 2, and the lowest point is minus 2. So the maximum and minimums have changed. So every y value was multiplied by 2. For 4 sine x, every y value was multiplied by 4. So now our maximum points are 4 on the y-axis, and our minimum points are minus 4 on the y-axis. Here we see the 2 this time is on the inside. So y is equal to f of 2x, or y is equal to sine 2x. So this time, every x value was multiplied by a half. So the reciprocal of 2, which is a half. So notice here that our y values have not changed. So we still have a maximum of 1 on our y-axis and a minimum of -1 on our y-axis. So the range is still between 1 and -1. And here we have the function y is equal to f of 3x, or y is equal to sine of 3x. So the 3 is on the inside of the brackets this time. So every x value is multiplied by a third, the reciprocal of 3. And again, the maximum points are still 1 on the y-axis and -1. So the range is still the same between 1 and -1. And then finally, for our trigonometric functions, if we have y is equal to f of x over 2, or y is equal to sine of x over 2. So it's inside the brackets now. So every x value is multiplied by 2 because the reciprocal of a half is 2. So again, the maximum and minimum points, they still go from 1 to -1, but the x values have changed.